this is Himabindu from the Department of CSIT. So today in this video I would like to explain about the Turing machine and its computation functions. So in the previous videos we discussed about the Turing machine as a language acceptor, and now in this video we would like to explain about the computation functions for the Turing machine. Yes, here the computing with the Turing machine. So Turing machine to compute the functions. So here we in previous videos we discussed about the language acceptors, the machine which we constructed for the language acceptor. And now the Turing machine, there is an option for computing the functions also. And here we can say that the Turing machine, in the previous classes we discussed about language acceptors. So Turing machine as a language acceptor, and now by computing the functions, so we can also, the Turing machine can also compute the functions as a transducer. And that is nothing but we are giving one input, and that is going to be changed by according to the functions what we are giving. Suppose here the addition of two numbers, we can say that two integer values can be added as a function. So here the function is naming as a addition. Like that, so many functions like factorial, multiplication, subtraction, addition, like that we can add the computation functions for the Turing machine. So here this Turing machines can also compute the functions. So here the language and also the language acceptor, and also we can use as a Turing machine transducer. So here language acceptors means the language which we are giving as an input, and according to the language or grammar we are getting the mission. So we are constructing the mission. So here like that we are giving some functions. So according to the functions we are giving input values, and we will get the result according to the functions. So here that is a Turing machine as a transducer. So apart from accepting the strings, Turing machine can compute functions also. So that what we discussed, the Turing machine as a language acceptor, not only a language acceptor and also a transducer. So that is nothing but computing the functions. So here the Turing machine can compute any numeric functions. So here we just discussed about the numerical functions. Why? Because we know very familiar with the addition, subtraction, multiplication. So like that. So numerical functions we take according to not only numerical functions, we can also we can also construct machines. For the Turing machines can also compute many functions. So here we just take in the numerical functions. So addition, subtraction, multiplication and factorial. So these are the numerical functions which are computed by the Turing machines. And also not only this one, many functions can be computed by the Turing machine. And we can construct a Turing machine to compute integer functions. So integers in Turing machine. So integer functions are also computed in this Turing machine. So here integers, while we are taking the integer value, that we will represent as a unary number. So unary number system we will represent. So that is unary representation means, suppose here we will take integer value 5. So how we will represent this 5 in the unary representation number system, in the sense we will write like 5 ones. And suppose 3 is there, we will write 3 ones. So this is a unary representation. After reading this one, after reading this ones, we already know that we are replacing the input values, and first we are reading, and we will write one more value to that tape. And let me briefly describe about the Turing machine tape. So this is, if it is a tape, that is also unlimited. So unlimited tape. So in this one, we will take the values, input values here. After reading these input values, we will write zeros. According to the functions, we will write the zeros. And what is that means? After reading this 1, we will write this 0. And this one also, after reading this 1, we will write 0. According to the Turing machines, we are performing the operations called read and write. And here, one more point we need to discuss. There is a header point. So there is a header point which is moving left to right. So what are the main operations? So operations, write down operations. So operations are read and write. Read, comma, write. So, and one more point we need to note down. One is a header control. So header control is nothing but this reading the input, where we are reading and in which place we are there. So that is nothing but head control. So this is head control, and this can move either left or right. So it based on the language or based on the functions. So previously we just discussed about the only languages, and now we also introducing the computing functions. So according to the computing functions or languages, we will move this header from left to right based on the functions or languages. And this is about the Turing machine tape. So here we will write first we will write the input into the tape, and if there is a limited input is there, the remaining all are placed as a blank symbol. So B, capital B, represent a blank symbol, and b- while performing the numerical operations called addition and subtraction. So let me write the addition and subtraction. Suppose here we'll perform the function called 5 plus 2. So for suppose this is the Turing machine which we want to construct, which we want to perform the function. So here 5 plus 1. So I will write 5 as a unary representation 5, and we will replace with blank symbol to separate these two integer values, and we will also write 1 and this b. So this is 5 and this is 2, and we will add the function, we will perform the adding function. We will replace this tape with 1 2 3 4 5 6 and 7. So here instead of B, whenever after reading the 5 input symbols of 1, whenever we saw the B symbol, that is a blank symbol, we need to replace it with 1. So that is the logic behind here to construct the addition of two integer numbers. So here this is how we perform the function called addition function for the Turing machine. So this is how computing the numerical functions for the Turing machine. And so Turing machine can compute the functions like y is equal to f of x. So here the y is the output. So y we are naming as a function name f of x. So initially the value corresponding to the x put on the tape, and Turing machine is run. So initially what we have to do, we discussed, right? So input value we need to place on the tape, like this is the, suppose this is the x value, we need to place on the input Turing machine tape. After having performed the computation, the result f of x replaces the original value. So that is nothing but after computing the function, in the sense the ones are replaced with zeros. So based on the function what we are taking, either it is addition or subtraction, whatever it is, based on the function value we need to get the result as a original value, replace the original value, and head returns to the begin. So and again this header where this after computing all the functions, the header is written back to the initial, and this is what we are discussed. The input is usually represented in unary format, just discussed, right? So one we are representing in the The input values what we are taking as a function value, so those are all represented in the unary format. So that is nothing but here 0 is represented as 1 and the 1 is represented as double 1. So totally if it is a function for the unary representation, so 0 is represented as 1, 1 is represented as double 1 and 2 is represented as double 3. Like that the one more 1 is added here to the integer value, that is nothing but we are representing as a 1 power n plus 1. So here n is equal to from 0 onwards we are taking 0, 1, 2, 3 like that. So 0 plus 1, 1. Like that 0 if it is for the n value, the integer value, the function value of this unary representation is 1. What we discussed. So let me write. So 0 if it is n is equal to 0 and 1, 1 plus 1, 2. So for this is for 0 and this is for 1, value 1 and 1 power 2 plus 1, this is 2, what we discussed. So this is about the unary format representation. So that is unary format representation 1 power n plus 1. So to add the two numbers m and n represented as 1 power m plus 1 and 1 power n plus 1. So here m and n values we are taking from 0 to n number. So suppose m is equal to 0 to 1, 2, 3, 4 and so on, and n is also 0, 1, 2, 3 and so on. So here to represent, to add the two numbers, not only we are taking, earlier we took only two integer values, that is 5 and 2. So whenever the addition is performed for the number of m and n value, function two numbers m and n values, we need to perform this kind of, we need to construct a Turing machine for this kind of functions. So how we will construct? So m is equal to 0 we will take first. So 0 plus 1 and so entire we will take it as m plus 1. So m plus n. So addition of this two, the sum of two numbers, we will represent it as a 1 power m plus n minus 1. So entirely for the representation, sum of two additions is represented as 1 power n plus 1, n minus 1. The set of arguments for the function, so here not only we are taking single, so here the single function is there and now we will take multiple functions. So is put on the tape as a string of ones and zeros having the values. So how we will perform this one? So here the separation of every function is divided by the b. So b is representing as a blank symbol. So here 1 power x1 and b. So to separate every function, so we are replacing it with the b. So b, suppose here this is b 1 power x1. So this is one function and here x1 to n, right? So here b and x2 and b x 1 power x3 and like that and so on. So so what is the iterations for the x power functions x power n. So this is about the functions so which we are taking. So this is a sum representation and we will construct a Turing machine for this function. So function computing with the Turing machine. To find out the sum of n plus m plus n, the arguments are stored on the tape in the begin. So here this is about, so b 1 power m plus 1. So this is one number representation and b m power 1 power n plus 1 b. So initially we will begin like this. So the functions which we are taking two two values, so two numbers we are taking. So the two numbers are also like this and after with id, so instantaneous description as q naught b1. So q naught is the initial state and So Q naught is the initial state here. We took this one. And whenever we saw the blank symbol, we need to replace it with a blank and we need to move to right side. We need to move to right side. And after that, we saw the Q1 state and we are reaching the next state. So Q1 state, and in the Q1 state, when we saw one, so when we saw 1, we need to replace it with 1 and we need to move to right hand side. So here, right. So whenever blank symbol is there, header, we move to the right side, and when we saw 1, we need to replace it with 1 and we need to move to right side. And 1 after all, that is repeated. So how many ones are there? We need to move to right side. So we need to move to right side. And after that, when we saw the blank symbol, so here when we saw the blank symbol, we need to replace it with 1. Read this and replace it with 1, and we need to move to right side. So we need to move to right side. After this one, this is the next state. So up to this one is, if this is a Q2 and this is a Q naught and this is a Q1, and here after reading 1, so from the Q3, so this is a Q3. So whenever in the Q3 state, when we saw the 1 as an input, so we need to replace it with 1 and we need to move to right side. So again this repetition, that how many ones are there, we need to move to right side. And whenever we saw the blank symbol, we need to we just move to the left side. So we are moving left side. And in the left side part, this is Q5. So that is Q5, that represents the ending of the second function, second number. So that whenever we saw the Q5 state, so in that one, whenever 1 is there, we need to move with the blank symbol and we need to move to left side. And again, when we saw the blank symbol, when we saw the 1 as an input, and we need to replace it with B and move to left side. And when we saw the 1 as an input, so here two B's are neglected, and here after this one we appear, we need to replace it with 1 only until we got the blank symbol. So whenever we saw the blank symbol, so there is no blank symbol here. Why? Because we already replaced this with B. So that's why whenever we saw the blank symbol, first blank symbol, we need to halt in this place. So this is about the addition. So instead here addition is nothing but M1. Suppose here we will take 4 as an input symbol, 4 1 power. So how we'll write 4 plus 1, so 5 ones are there. So 5 ones, and we'll take 2 number 1 plus 3. So here we will write 3. So and here after adding all the numbers, what we will get, we have 8 number. So like this we will for this input also we will check for the computation of addition. So like this we constructed the Turing machine for the addition. And next, primitive recursive functions. So here the primitive recursive functions, that is nothing but a successor function. So successor functions, or all computations in Turing machine can be done using primitive recursive. That is nothing but PR, primitive recursive. And the 0, Z and successor functions are primitive recursive, and composition of PR with PR or PR. So here the computation of any two functions can be resulted output as a PR, primitive recursive function only, and nothing else, or PR. For example, if to find 3 plus 2, we can do this by successor, and this is nothing but successors of success 3. and which is composition of functions S with itself. So itself we can do this performance, do this function, that is nothing but successor function. And if the n is an integer represented as a unary representation, we already discussed. So a 1 power n plus 1, then its successor is with the 1 power n plus 1 only, and can be computed by the Turing machine like this. So this is about, so B, whenever we saw the B, we need to replace it with B and we need to move to right side. And here whenever we saw 1, we need to move to right side until we got the value B. And whenever we saw B, we need to replace it with 1 and we need to move left. And this until we find the B value, we will find the we will be in the halt position. That is nothing but initially wherever the header starts, they are in the initial state only. The header is here only. We need to replace this B with the B, and here we need to halt. So this is about the successor function, and the successor function for binary representation. So here what are the rules we have to follow? So if we read 1, write 0. So write 0 and go right. So 1, if there is 1, we need to replace it with a 0 and we need to move right. And if read 0, write 1, rewind and halt. So if 0 is there, we need to replace it with 1 and we need to move. We should be there in the halt position. And if you read B, blank symbol, write 1. So blank symbol is there, we need to replace it with 1 and rewind, halt in position, halt. So this is simple rules for the binary representation. So here we will take one example, the 47 representation, binary representation. So reverse number. So till now we discussed a unary number. So unary numbers are nothing but only in the form of ones. Here we will take the binary numbers. So successor function for the binary numbers. So binary numbers are nothing but two values 0, 1 we have. So 47 is represented in the binary form like this. So this one is the number which we are binary representation of 47. And successor function of 47 is nothing but the successor of 47 is 48. So successor is nothing but adding one value. So adding one input value, one integer value to the given input value. So here what is the result? We will get 48 as a binary representation. And here this is the 47 value which is in the binary form. And what we discuss simple rules. So in that rules, whenever we saw 1, we need to replace with a 0 and we move to right side. So and here that is until how many ones are appeared in the until how many ones are appeared, we need to replace the 1 with a 0 and we will need to move to right side. And whenever we read a 0, write 1. And here whenever we read 0, we need to write 1 and rewind, halt. So we need to rewind, halt. And whenever if B is read, B is there, we need to write 1. We need to write 1 and rewind, halt. Rewind, halt. So this is finally we got double 1. So rewinds, halt, that is nothing but the result is 48, the reverse order. So the successor output of this input value 47 is, this is the value what we need to reverse in the binary representation. So 48 which is a reverse. So why? Because we replaced 1 with 0. So if you write this in the reverse format, we will get, this is 48 representation of binary number, representation of 48. So this what we discussed, we constructed a Turing machine. So B, whenever we saw B, B is replaced with B only and we are moving to right side. And whenever we saw 1 and we need to replace with 0 and we need to move to right side. Until we find one many number of ones, we need to replace with the 0. And here there are two cases. When we appear B blank symbol, after reading all the ones, we appear blank symbol, we need to replace with 1. And 0 appears, we need to replace with 1. And B appears left side, and we need to replace 0, 1 with the right side. So this, and when after reading this one, when we saw 1, this part is nothing but we are moving from left side. So that is nothing but we are coming back to the initial state. So initial state, so on many ones or zeros are there, we need to move to left side until we saw the blank symbol. So after blank symbol, we have to stay back, and that is nothing but halt position. So here, this is about the binary representation successor function and primitive recursive function. So that is nothing but 0 function. So successor one, in primitive recursive functions we saw that successor function. Now we will discuss about the 0 function. So 0 function, it effects is to make tape contains equal to 0. So equal to zeros. The 0 function is nothing but we have to replace all with the zeros. If contains the tape of 1 power n or 1 power m, after running 0 function, the result of the tape is 1. So which stands for 0. So entire after performing the 0 operation, we just discussed 0 tends to 1. Unary representation. The following Turing mission for the Turing 0 function is, so whenever we saw the blank symbol, we need to move to right side, and 1 we appear, we need to move to or we need to move to right side, and 1 appear after getting blank symbol, we need to replace with the blank symbol, and we need to write move to right. And whenever B appears, so until we saw the last blank symbol, we need to move to right side. And after seeing the blank symbol, we need to move to left until we have to write all the with blank symbols, and only single one we need to be replaced. So 1 is there, we need to move to left side, and we need to be in the halt position. So this is about the 0 function, and and here the pred function, that is nothing but primitive recursive function, pred function. So a partial recursive function, it is a partial recursive function. Its effect is to make the tape constant reduced by 1. So the successor function, and this function, partially recursive function, is different. What is the difference in the sense? So there in the successor function, we will add one input, and here we will reduce one value by 1. So if contains the tape 1 power n plus 1, after running this spread function, the result is 1 power n. 1 power n. However, if it is a 0, the pred 1 of 0, 1 is 0. And because the predecessor of 0 is 0 only, since we are dealing with the positive integers. So here we are dealing with the positive integers. So 0 tends to, so successor producer of 0 also, it is a 1 only. And why? Because we are dealing with the positive functions, positive integers only. And for that one, what is the Turing mission? So whenever we saw the blank symbol, we need to replace with the B only. And whenever 1 is appeared, we need to move to right side until we find the 1. Until we find the blank symbol here. And after the blank symbol, we need to move to left side. And again, when we saw 1 appear in the left hand side, we need to replace it with a B, and we need to move to left side. And here also 1 appears, 1 we need to replace, and we need to be in the left hand side. And blank symbol appears, we need to be there, we need to be in the left position. We need to replace with the B, and we need to be in the left position. So this is about the pred function, which is a reduced function, the partially recursive function, which is a reduced function, reduced by 1. So these are all about the functions, computable functions by the Turing machines. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.